Hello, welcome back to Fractional Calculus. My name is Sunday Oluwafemi Bodugbe. Alright, before we move a little bit further, let's check this factorial. Then we know that this question of fractional calculus does not just begin in the derivatives. You will recall when we have n factorial, the result will be n minus 1, n minus 2, n minus 3, dot, 3, 2, 1. If you have 1 factorial, you have 1. If you have 2 factorial, that will be 2 times 1. If you have 3 factorial, that will be 3 times 2 times 1. If you have 4 factorial, that will be what? And then you get that 4 times 3 times 2 times 1. Good. But what if you have half factorial? You want to try it? Alright. So you need to note that this our n, the value of n factorial, our n here is a positive integer, and our n here is only value. This our n is a positive integer, that is 1, 2, 3, 4, 5. You see that? Okay, and etc. So what will happen when our n is now a fraction? That is the question. What will be half factorial? It's a question. So you can see that this matter of fractional has been a long time challenge that mathematicians have been facing. So at this instance, a mathematician called Euler introduced what is called gamma function. Gamma function. So at gamma function, we have gamma function of n is given as integral 0 to infinity exponential minus t is power minus n minus 1 dt. So these extensions of fractional factorial function. So with this now you can calculate arbitrary number. So with this now we can able to find when n, we can able to find half factorial, 1/3 factorial, pi factorial, etc. So I want you to take note of this because we need it in the long run. Alright, so let me now come back to the fractional calculus. So but before then, can we just do a quick review of our classical calculus? If we have y, okay, classical calculus. If we have y equals to x squared, so let me use xn now, and our n is our positive integer. So dy dx will be what? Yes, n xn minus 1, right? So if we find the second derivative, that's y, that x squared, we have what? n minus 1 sn minus what now? 2. Brilliant. So what if we have that 3 y, that s3, that will be what? n minus 1 n minus 2 and what? Yes, sn minus 3 over what? Okay, good. So now I want you to see something here. I substitute this. Just take a cool look at this. This man, that 3y, that s3. If I write it in this form, n minus 1, n minus 2, n minus 3 factorial, then everything over immediately so that I will not break the rule of mathematics. N minus 3 factorial x n minus 3. I believe that this is still equals to this, right? Good. So now, instead of this n minus 1, n minus 2, n minus 3 factorial, I can just write it as n factorial. Agree? Good. Over n minus 3 factorial, and then x raised to power n minus 3. So that is that 3y the x3. So with that, now I can write a general derivatives as the n y over the xn. Okay, let me use k because we have this n factorial. So the k y over the sk will be equals to what? We just substitute the value of n where we see 3. We substitute 3 for k. That will be n factorial over n minus k factorial x n minus what? K. So this is the, and that is where our k is a positive integer. Positive integer. So this is the general formula of our classical derivative. Is that taken? Alright. So, but what if we now decided that with this, let's substitute our k to be equals to alpha, where alpha is now a real number, that is alpha is now cannot be fractional into this our equation. So in that we make this, let me call this equation star to be the alpha y over the x alpha equals to, don't forget it is only k, we substitute k for alpha, n minus alpha factorial x n minus alpha, where alpha belongs to a real number. So, but we know that the factorial of fraction does not exist, so we have to substitute it with the gamma function, and that is why first of all express this. Is that taken? So, and don't forget gammas have some properties. Let me just write the gamma properties out here. We have some properties of gamma, properties of gamma function, and it will be very useful for us in this fractional calculus. We have gamma n plus 1 is equals to n factorial, and then we have properties 2, gamma x plus 1, that is x gamma x, and this is n is is integer, but this x is now a fraction. It is now a real number and can be fraction, and the gamma half is derived as root pi. So take note of these two properties. So if we now substitute this, if we substitute this in this, if we substitute this, that this our fraction combination, which is n minus alpha factorial, into this, that means that, sorry, if we substitute it into this first properties, our n prime factorial, that means that we're going to have gamma n minus alpha plus 1. So we take it back to our equation. Then we have an equation we can use in order to find the fractional derivatives of calculus. So we try to implement this formula in our next class. So we have the alpha y over the x alpha equals to n factorial over we substitute that now. That will be gamma n minus alpha plus 1, and then x raised power n minus alpha. So take note of this formula. So, and also instead of this notation, there's a general notation we do use to represent our fractional derivative, and that's capital D, then alpha y, which is the function, then I put this in bracket, the function of y, n factorial over gamma n minus alpha plus 1 x n minus factorial alpha. So take note of this formula. You can go back through the video again and watch it over and see how we derive the formula. Very simple, very easy. And if you have any question or comments, you can drop it at the comment section. So in our next class, we will implement this formula to find derivatives of some functions. I thank you for watching. See you in the next lesson.